Hello everyone, and welcome back to another Mathematics and GIS lecture video. And in this lecture video, I want to talk about something called the area of a sector. And I want to sort of explain what a sector is, and then conceptually explain how we can use the information that we hopefully know to figure out what the area of a sector actually is. So let's start off with what a sector is, right? And so if we have a circle with a center and some radius r, right? Some radius r. This is going to look exactly like the diagram we've drawn so many times before. All right, we go along this circle, some arc s, and then we connect that up with a second radius right here. All right, what we've done is we've actually created what's called a sector. Right, this yellow piece right here, this is called a sector, or a section or a slice of a pie or a circle. This is called a sector. And you might think to yourself, well, maybe I want to know the area of this. So how would you go about figuring that out? Well, luckily for us, we can use some proportions here. Right? So we know that S, right, which is the length of some arc, right, is subtended by theta, which is the angle that subtends that arc. Measured in radians, right? And we know that if we were to go all the way around, right, if this arc went all the way around to become a full circle, right, that angle that subtended that would be 2 pi. So what we know is that theta relative to 2 pi, right, so this is the angle of the arc, and 2 pi, right, this 2 pi here, right, this is the angle of a full rotation. Right, hopefully this makes sense, right? The angle of the arc, the angle of a full rotation. Right, this ratio is going to be the same as the area of the sector, which I'm going to call A, right? So the area, we're going to call that A for the area of the sector, right? A is going to be equal to the area of the sector, right? Relative to the full area of the circle, which is going to be pi r squared, right? Pi r squared is just the area of the circle. We know these two relationships are going to be equal to each other. Hopefully that makes sense. So what we can do now, because we're assuming that we know theta, or that we can figure theta out, is we can solve this equation and we're assuming that hopefully we know the radius as well, that we can solve for area. So what we do is we would do area, right, multiply both sides by pi r squared, is going to be equal to theta times pi times r squared divided by 2 pi. Pull out my red pen here, right? These are going to cancel. And we're going to be left with 1/2 times theta, which is, again, the angle that is subtending the sector, right? 1/2 theta times r squared. So if we're given either the length of the arc that goes along the outside of the sector, the angle that subtends it, and or the radius of the circle, we can figure out the area of this sector. Again, I want to walk back through this again because I know there's a lot here. Right? Given some sector with area A, an arc length of S, and more importantly, an angle of theta in radians. Let me make sure that gets highlighted. In radians. This has to be in radians. Right? We can use the ratio of that angle in radians to 2 pi is going to be consistent with the ratio of the area of the sector that we're trying to get relative to the entire area of the circle. Then we can take that equation and we can rearrange it to solve for a by multiplying both sides by pi r squared. That's what this is. The pi's cancel from the top and the bottom. And so what we end up with is the area only caring about the angle of the sector that you're looking at and the radius of the circle. That's the beautiful part of this equation is we no longer care about pi. Right? This is going to hold true for any circle. And we no longer care about pi. All we care about is how wide the circle is, right? That's this radius here. And how much of the circle we're encompassing. That's what this theta is here. Hopefully that makes sense. I encourage you to go back, watch any parts you're confused about, and as always, please reach out. Thank you.